Hello, welcome to Ludic Science. In this video I will show you this circuit to flash an LED, but with this effect of gradually turning on and off. The LED flasher circuit is one of the first that we learn to make when we are starting in electronics. There are many variations of the circuit. You can make it with different topologies, and this one in particular uses a couple of operational amplifiers to do the job. The advantage of this version is that you get this effect of the LED turning slowly on and slowly off. Next time you need a PCB for your electronics project, consider using the professional services of LCPCB. LCPCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. Here we have the schematic. As we said before, it is based on two operational amplifiers. It is the LM358, which actually is a single IC that contains two operational amplifiers inside. The numbers here are the pin numbers of the IC, and the arrangement of the pins is shown now on the screen. The first operational amplifier produces a square wave, and then it is fed to the second amplifier that converts the square wave into a triangular wave. So the current starts to increase, which causes the LED to slowly turn on, and then decreases, which is when the LED turns slowly off. We have here a capacitor which controls the frequency. It has a variable value depending on what frequency we have. So its value is around 1 microfarad. We have here a transistor to amplify the output current of the second operational amplifier. You can use any small signal transistor, such as the BC337, and here we have our LED, and you can feed the circuit with around 4 to 6 volts DC. So let's now see the circuit working. Here we have the circuit working. You can see how the LED starts slowly to turn on, reaches its maximum bright, and then also slowly turns off. Right now I am using a capacitor of 1 microfarad, which gives a frequency of around 3 seconds. But let's change it. I'm going to use this other one, which is 0.47 microfarads, and we should get a higher frequency. Okay, there it is. Now the LED is blinking faster. And let's now check with the oscilloscope the output of each operational amplifier. As we said, we have two operational amplifiers in a single package in this IC. Let me connect the scope first to the pin 1, which is the output of the first operational amplifier, and you can see that we have a square wave. Now I'm going to connect to pin 7, which is the output of the second operational amplifier, and we have the triangular wave. So the LED turns on slowly, maximum brightness, and then slowly turns off. Okay, so there you have it, a blinking LED circuit with the function of slowly turning on and off. Thanks for your visit. I hope you liked this video. See you in the next one.